Hey everyone, welcome to the session on making Kubernetes resilient with LitmusChaos. This is Sarnya and I work at Harness.io as a senior software engineer, and I'm also one of the contributors to LitmusChaos.
Hello everyone. I'm Nilanjan, a software engineer working at Harness, where I'm building chaos engineering at scale for every organization. I had started my chaos engineering journey at Chaos Native, the company behind the Litmus Chaos framework, which is an open source CNCF incubating project for performing chaos engineering in cloud native environments. In my day-to-day work, I'm responsible for assessing the chaos engineering requirements for any given scenario and authoring the chaos experiments that can suitably validate the resiliency of an application for that scenario. From my experience, I can tell you that the successful chaos engineering practitioners come to master the skill of fabricating every chaos experiment on a case-by-case basis to leverage the most results out of each experiment. Therefore, it is crucial to emphasize on the right kind of experimentation with realistic hypotheses to simulate real-life failure scenarios that can affect your application, as I'm going to show in my upcoming demo.
So, today's agenda will be first of all, we'll be talking about chaos engineering. What is it and why do we need chaos engineering? Then we will be introducing Litmus Chaos, talk about its core components and features. And then lastly, Nilanjan will be giving a short demo of how chaos can be injected in an application. So, without any further delay, let's get started. Talking about the era of cloud computing, according to the recent reports of O'Reilly, cloud adoption has been rising steadily with around 90% of organizations already using it, and 75% of respondents are working in an organization which has cloud infrastructure. E-commerce and retail, finance and banking, software are the proactive ones. However, with the increasing adoption of cloud, for all its benefits, there also comes some challenges as well, and downtimes are one of them. Outages and downtimes are expensive, and according to ITIC 2020, 1 in 4 enterprises have indicated that a single hour of downtime can cause a loss of somewhere between $1 million to around $5 million. And not only that, it comes with also some major core impacts as well, such as loss of the top ones are loss of customer confidence, damage to brand integrity, loss of like employee morale, and diversion of resources, etc. So the need of the R is to mitigate, if not eliminate, the predicament of the downtimes. By breaking things on purpose, we get to see the behavior of the application in a whole new light. And this diagram is a very basic flow of how chaos engineering can be practiced. First of all, you identify the steady state conditions of the application. Then we intentionally introduce a fault, and then we continue to check if the SLOs are met or not. If yes, then the application is resilient, and if no, we identify the weakness, work upon it, and then chaos engineering can be practiced again as a part of the cycle. So yeah, now it's time to introduce Litmus Chaos, which is an open source cloud native chaos engineering framework. It is also a CNCF incubating project with adoption of across several organizations. Here are some of the stats. Litmus Chaos has around 52 experiments with over 2.5k plus GitHub stars, more than 88k experiment runs. So yeah, talking about the core components of Litmus Chaos. Litmus Chaos at its core has two components there. First one is the chaos center, which is the single source of truth of all the chaos activities, be it creation of chaos workflows, scheduling them, managing the team. All these chaos activities are managed through chaos center. And the second one is chaos agent, which is nothing but a target cluster where the chaos against which the chaos is injected. Coming to chaos center, we'll talk about some major features that it provides. First of all, we have the chaos workflows. Litmus Chaos provides has the concept of chaos workflow, which is nothing but an orgo workflow where more than one experiments can be added either in serial manner or parallelly, and Litmus also provides multiple options to create these workflows. Users can do it from templates, or they can create their own custom workflow by from scratch, or can use the predefined pre-created YAMLs. Once these workflows are created, it these can be scheduled either as cron workflow or as a singular run. And Litmus also provides the feature of attaching priorities to the chaos experiments in each workflow based upon your own use case. Then coming to workflow management, first of all, it has GitOps. I will be talking about it a bit later. Secondly, it also provides it allows addition of image from your own custom image server, which can be either public or private. Then once the chaos workflows are executed, users can measure and analyze the resilience score of the workflow. Then Litmus also provides the multi-tenancy support, where users can create their own team, then run workflows, and each of the resources have comes with very flexible role-based access controls. And yeah, so it has also scope support, which can be either like namespace scope or the cluster-wide scope as well. Then it also supports monitoring and observability, where users can connect their own data source, visualize the workflow runs and the schedules, their statistics, and users can also compare two or more workflows, and upload and fine tune their own dashboards. And lastly, they can also monitor the chaos in real time. Then coming to the GitOps for chaos, GitOps, once enabled, provides a single source of truth for the chaos workflows. That means that these chaos workflows will be synchronized bidirectionally between the chaos center and the Git source. Secondly, it also supports tracking, which provides an event tracker, which is a microservice that is used to automatically launch the subscribed workflow in case there any changes happen to the target application, such as app upgrades, etc. Lastly, Litmus also provides non-Kubernetes chaos, where you can perform chaos engineering on infra resources, then attack bare metals or on any machine. Okay, so demo time. I'll hand over to Nilanjan, who will be showing us a very brief demo. Thank you.
Hey there, let's get down to creating some chaos with LitmusChaos. But before that, do you love socks? Oh, come on, everyone loves socks. So, let me bring you SockShop, an online e-commerce marketplace where everyone loves to buy their socks. What's so special about this application is that it's completely made out of Kubernetes microservices. You have a bunch of deployments, replica sets, and so on. Sounds like a perfect recipe for chaos to me. So as part of this demo, what we are going to do is we are going to inject some chaos into our SockShop application. What we are going to do today is perform one of the most popular LitmusChaos experiments called pod delete. And as the name of the experiment must be suggesting, we are going to delete some pods today, but which pods? Well, as part of this SockShop application, you have a catalog. The catalog lists down all the socks which you can currently buy. And this catalog is enabled by a deployment by the same name, that is catalog. And under this catalog deployment, we have a bunch of pods which are actually deploying this catalog, which is enabling us to view this catalog. So, as part of this experiment, we are going to actually delete a few pods from this catalog deployment. So let us hop into our Kubernetes terminal and let's see that what are these deployments look like. So over here, you can see that we have our SockShop namespace in which we have a bunch of deployments, and one such deployment is catalog. As you can see, as part of this deployment, we have exactly 2 pods and both of them are in running condition right now. So let me ask you that what do you think will happen if we just go ahead and delete both of these pods for a certain chaos interval? What do you think? Would be able to access our catalog even if our pods are gone? Well, let us find out using LitmusChaos. So let me just hop right into our Chaos Center, and with that I'll go ahead and schedule a workflow. Let me just select the self agent since my application is also deployed in the same cluster in which LitmusChaos lies. We'll go next, and I'll choose the creation of a new workflow using Chaos Hub. So what is Chaos Hub? Well, it is an open source marketplace for all the different chaos experiments you have available as part of LitmusChaos. So I'll select the Chaos Hub and just go next. Let us specify our workflow settings. Let us name it as pod delete, and in description we can simply say pod delete workflow. And with that, let's go next. So here in the tune workflow, let us add our first chaos experiment, that is the pod delete experiment. And as you can see, we have successfully added our pod delete experiment as a next step to the install chaos experiments. So what this graph is trying to depict over here is that we'll be first installing the pod delete experiment, and then we'll be actually performing the pod delete experiment. And with that, let's first of all configure our pod delete experiment so that we can target our sock shop application. So once I'm actually editing the pod delete experiment, you can see that we have the option for specifying the hub, which we have already done, the name of the experiment and the context. We'll leave them as it is. And then we have to specify our target application, that is the sock shop application. So first of all, we need to specify our namespace. So this will be the sock shop, since our application is in sock shop namespace. Then the kind of resource that we want to target. So as we saw, the catalog is a deployment that we have in the sock shop namespace. So we'll select this as deployment. Then we'll be specifying the label that we want to target. So we are going to select name is equal to catalog, since that is the label of our deployment that we want to target. That is the catalog deployment. So let us go next. And with that, we are good to add some probes as part of this workflow. So what are probes? Well, probes simplify the process in which you are declaring your hypothesis for this experiment. Probes help you to automate the process of hypothesis checking as part of your LitmusChaos experiment. So as part of this pod delete experiment, we can definitely define some probes which can help us to automate the process of checking that whether our pod delete experiment is resulting in a successful hypothesis condition or not. So what is the hypothesis condition that we want to define? Well, we just want to be ensured that while we are deleting our pods, while we are performing our pod delete experiment, our catalog should still be available. So how can we ensure that? Well, I'll like to show you an API endpoint that we have over here. So it is the catalog API endpoint, which is actually enabling the display of all these items that are over here. So as you can see right now that this catalog API endpoint is still available. If I refresh this, we are still getting all the information of the socks that are available to us. But the question is this catalog endpoint will still be available once we are deleting our pods? So let us try to validate this exact condition using the Litmus probes in an automated fashion. So back into my Chaos Center, let me just add a new probe. I'll name this catalog probe, and it is a type of an HTTP probe. Why an HTTP probe? Well, let me just define the probe, and I'll explain to you that why are we doing an HTTP probe. So we need to add some timeout as part of this probe. That is, after which time we can say that, well, our HTTP probe has timed out. So we can say a timeout of 3 seconds, and let us just retry twice with an interval of 3 seconds. And this HTTP probe expects a URL. So here's where we are going to actually put the URL that we copied from our catalog API endpoint. I'm putting this over here. And what we are going to do is we are actually going to send some GET requests at this API endpoint. And the criteria that we are going to check for upon each of these requests is whether we are getting a response code of 200 or not. So as you know, if we are getting a 200 response code, it means that everything is fine. We are still able to access our API endpoint for the catalog, and therefore we should be able to still access our catalog in our application. But if we are not getting a 200 response code, then it certainly means that something is off, something is not quite right. And therefore we can say that, well, our hypothesis is not validated. It is therefore right now invalid. And therefore we can flag the experiment as failed. So let me actually define this. And as you can see, the catalog probe has been added to this experiment. Let's go next. And finally, we are in the part where we need to tune the experiments. So we need to provide a chaos interval as well as a chaos duration. I'll select 30 for both of them. And then we have the pods affected percentage. Well, what does this mean? As you saw that as part of our deployments, we have a few pods, 2 to be exact. And right now we want to delete both of these pods as part of this experiment. So we can give 100%, which will mean that the experiment will go ahead and delete both of those pods that we saw earlier as part of the catalog deployment. With that, we are done tuning our experiment. We can say finish, and let's put reverse schedule as false, since we would like to see the logs of this experiment once we are done. So let's simply go next. And we are here where we can specify the reliability score of this experiment. Well, what this does is basically you need to set a score that you need as part of your final resiliency score calculation. So let us set the weight directly to 100, that is 10, which will cause us to have full weightage of this experiment. Then we can go next. Well, we want to schedule now, so we can just keep it as such, not create a recurring schedule. And let's just finish with our experiment and see what happens. As you can see, our workflow has been created right now and it is currently in the running stage. So let us wait for our chaos experiments to get installed and the pod delete experiment to start. So as you can see over here, the pod delete experiment is just about to start. And here we can see that the pod delete experiment has actually started. So how can we confirm that, well, whether our pods are still available to us or not, since the pod delete experiment has actually started, right? So let us head back right to our Kubernetes terminal. And as you can see, since as part of this experiment, both of our pods have been deleted. In order to confirm this behavior, let's just hop onto our SockShop application and try to reload this page. So as you can see, the pod delete experiment has actually caused both of our pods to go missing, and therefore we cannot see anything here in our catalog. But the most important part of your chaos experiments is observability. You need to be aware that something is not quite right while you are running these experiments, which is paramount to understanding where your application is weak. LitmusChaos provides an observability panel right as part of your observability stack, and it uses external data sources such as Prometheus in order to generate your application dashboards. So as part of this observability dashboard for SockShop, as you can see, at this specific time, our pod delete experiment has been started, and you can see that our graph is going down right now. So while our other metrics such as orders or like payment, everything is fine since the beginning of the chaos experiment. As you can see, the catalog is not the same. The queries per second from catalog is progressively going down since we have injected this chaos. And at the same time, the catalog latency is also going very high since there are no pods at the moment to serve the requests. We can validate the same using a Grafana dashboard which we can set up as part of our Kubernetes. So we already have a Prometheus, we have integrated Grafana with it, and as you can see, during the chaos interval, the annotated portion, you can see that our queries per second for catalog metrics is going down, as we had seen earlier in our chaos center observability stack. And in a similar fashion, the catalog latency is going way above for the same reason that the pods are not there anymore, and therefore our queries are not being served. So we have therefore confirmed that how LitmusChaos pod delete experiment can basically delete your application pods, and you can also utilize your observability stack in order to understand that where your application observability is lacking or what is going wrong. You can definitely find that out. So with that, let's wait for some time for our chaos experiment to complete, post which we will be able to see the different logs. Alright, so our application, our experiment is right now completed, and as we can see, the experiment was unsuccessful. But why is it unsuccessful? Before we get into that, let's just dive right into our Kubernetes console to see that whether the experiment effect is reverted or not, that is whether our pods are back here or not. And as you can see that, well, the pods are indeed back, the effects of this chaos has been reverted, and we can confirm the safe if we go to our application and if we try to reload. As you can see, the catalog is again back. We are right on track. But it is paramount to understand that what caused our chaos experiment to fail. Why has it failed? And to do that, we can definitely view our logs, the experiment logs, right from our chaos center. So let us try to inspect the logs in order to understand that why exactly our chaos experiment has been marked failed. So we can see the different stages of the experiments demarcated over here in our logs. And as part of this experiment, you can see that we are deleting two pods. First of it is this catalog pod and this second pod. As we are going into our experiment, you can see that we are starting the chaos interval of 30 seconds here. And while we are actually starting our experiment, you can see that during the chaos interval, our response code is actually 500. It is not what we had earlier expected, that is 200. And therefore, this has been the main reason that why our chaos experiment failed, because the probe that we had defined for the validation of whether our catalog endpoint is available or not, well, that failed because we didn't get an actual value of 500, sorry, 200, and the actual value that we received was 500. So that's how you will be assured that why exactly your chaos experiment failed, and you can therefore take measures to improve the application resiliency. As a final step, you can also verify the chaos results. The chaos result basically displays that a summary of your chaos experiment. So as you can see, the experiment status is completed, but the verdict is failed. And the reason for that is basically the probe success percentage is 0. The catalog probe that we had defined, which is an HTTP type of probe, it failed. And therefore, we come to an end of our demo. We saw that how we can use LitmusChaos in order to make our Kubernetes cluster more resilient by testing out different chaos scenarios using different chaos experiments. We saw how the pod delete experiment helped us in order to validate the resiliency of our application, the sock shop application, and we saw that how we can observe the chaos in real time using our observability stack. So that's it for this demo. Thank you.